So what it seems is happening is that high chronic workloads actually prepare your players to handle the sprinting demands that they're required to perform in competition. The other thing that I commonly get asked is, well, why is it that some players break down at a ratio of 1.5, whereas others can just keep going? And this is a really important point. These are what we call moderators of injury risk. So when we look at moderators of injury risk, one of the key factors for football is aerobic fitness. When you have well-developed aerobic fitness in the green, and this is just maximal aerobic speed from a time trial, when you have well-developed aerobic fitness, your risk of injury is really low. But when you have poor aerobic fitness, your injury risk is 5 times greater. Now, this is at a given spike in load. So when we say a spike in load is a ratio of 1.5, if you have poor aerobic fitness, you're less able to handle that spike. For young and old players, it's a U-shaped curve. So our young players aren't very tolerant to spikes, and our old players aren't very tolerant to spikes. We've also seen the same thing with strength, and this is lower body strength, just tested using a trap bar deadlift, and we've expressed it relative to body weight. This is 3 times your body weight, so the ability to deadlift 3 times your body weight. When you're really strong, your risk of injury is really low when you're exposed to spikes. But if you're relatively weaker, again, we're looking at a 5 to 6 times greater risk when we expose that player to spikes. So when we talk about our resilient and our fragile athletes, or our robust and our fragile athletes, and we say, well, why is it that one breaks down and the other one can keep ticking along? Part of it comes back to physical qualities. It's not the only thing, but it's one of those things that allows players to handle spikes in load. So how do you get that strength and how do you get that aerobic fitness that allows you to cope with spikes in load? Well, you actually have to train, and if you train appropriately, then it improves your ability to develop those physical qualities, it improves your chronic load, which in turn improves your ability to handle spikes. Commonly I get asked, well, why 1 week and why 4 weeks for the acute and chronic ratio? Well, I used that as an example in the original paper. It wasn't meant to be set in stone that it has to be 1 week and it has to be 4 weeks. We use 1 week in Australia because we tend to play from week to week, and our microcycles tend to be a week long. We use 4 weeks in Australia because typically we work on 4-week mesocycles. But as I said this morning, your acute load could be as short as 1 training session or 1 day up to, say, a week. And your chronic load could be anywhere between, say, 3 and 6 weeks, because that's around about what it takes to develop physical qualities. That's the amount of time it takes to build chronic load. What I would suggest is if you're working with a sport that involves a high endurance capacity where you have athletes that are working closer to the ceiling and therefore it takes a little bit longer to change physical qualities, then you probably need a longer chronic training load period. And equally, if you're working in a congested sport, such as basketball, where you're playing multiple games in a week, or football, then you could probably work on a shorter acute training load period.